Okay, welcome class. Today what we are going to be doing is we're going to be taking a look at section 1 in your textbook, which is all about physical and chemical change. So we're going to throw out some terms at you, and we're going to practice this whole video learning kind of vibe thing that we're going for this year. And then we'll do some discussion and we'll do some practice, and then you're going to upload an assignment into Cami today. So that's what we're going to do. So let's get at it. All right, so first off, you're in chemistry. So what are you going to be doing? Well, you're going to be studying matter. So the actual definition on this slide is the study of the composition, structure, and properties of matter. Basically, we are going to be studying stuff, and stuff is matter, and how it interacts with other stuff. You know, think about it. Why should you run if you see someone smoking as they're pumping gas? Well, we know that gasoline, that stuff is highly flammable. That's one of the properties of it, which we're going to be talking about. And so in chemistry, we look at how things behave. We try to understand their structure. We try to understand that in our world. And this is they call it the central science because everything's based off of it. So a lot of people take chemistry, and it's all about the study of stuff, matter, and how it interacts. So, one of the things you'll be doing later on is you'll be defining things in terms of your own words. So you can use these long words on this paper here or this computer screen, but also think about it. It's how can you simplify it, make it a bit easier to understand. Okay, so when we're studying stuff, matter is anything that has mass, takes up space. So again, a nice way to say it is how much stuff you are. All right, what's matter is stuff. Now I always ask, what is something that's not matter? So you look around, the desks are matter, the air is even matter, takes up space. The ceiling tiles, the board, everything's pretty much matter, except things that aren't matter, like feelings. Oh, so like love isn't matter. You can't have a physical, there's no like physical thing. It's a feeling, right? Or an action. Energy isn't, matter. So if you're looking at light, that's not technically matter. So these kind of things are something to think about, but anything that has mass takes up space. Mass is the amount of matter you have, and space or volume is how much you occupy. That is matter. So again, think of, as you watch these terms, you might want to jot down some notes and then think about how you can shorten these terms, because you're going to have to write them out and know them in a simplified way. Okay, so when we talk about matter, stuff, okay, there's different ways that we can describe it. And one of the ways we can describe it is we can actually measure it. And so an extensive property is something that deals with the amount of matter present. So for example, you eat McDonald's for like 5 weeks in a row, you could change your actual mass or the amount of matter present. Okay, and if you starve yourself for like weeks, you would change your mass and then it would differ. So the properties would change. And so it depends on how much is present. A nice way to look at it is like, I have this pen. This pen, if I chop it in half, the length is halved. So how much, things that are extensive are like volume, mass, the amount of energy present in a substance. These are all extensive properties. A lot of these are measurements, but you have to be careful, and I'll explain why in just a second. So intensive is the opposite of extensive. It means it doesn't matter how much you have. And these are things that are independent of amount. Okay, so water always freezes at 0 degrees Celsius. It doesn't matter if you have a whole bunch of it or just a tiny little bit. Now, how long it takes or the amount of energy present is going to depend upon, the amount. So that would be an extensive property. So for example, Lake Erie, it takes a while for it to freeze over. We're all close to Lake Erie here in Ohio. So, that's it would be an extensive, the amount of heat present. But melting point is totally intensive. It doesn't matter how much you have. Butter melts at a certain temp, chocolate melts at a certain temp. That is intensive. It's always the same. Boiling point, same thing. Density. Okay, so density, an object is, if it's more dense than water, it'll sink. So for example, if I have a hunk of metal always sinks as long as the shape is the right shape. So let's not go there. But regardless, if you cut it in half, the density still remains the same. So because density is mass divided by volume, and the ratio stays the same. So it is definitely intensive. Ability to conduct electricity, color, texture, any physical property that describes matter that doesn't matter how much you have. So again, I go to my trusty stylus that I use here, it's black. Okay, now if I cut it in half, it's still black. Now if I cut it in half, the length changes, that's extensive. ability to transfer heat, conductivity, all those things are intensive physical properties. Okay, now, I mentioned that term physical property. Physical property is a characteristic that can identify an observed or measured amount without changing the identity. Okay, so this would be, if I was to put this in my own terms or shorten it, this is some sort of description of matter that doesn't change it, okay? That doesn't change the identity. So like when an object goes through a phase change, so solid, liquid, gas, when things melt, when things, as long as that substance doesn't change its identity. Think about water. If you have an ice cube, right? That ice cube is a solid, and if it melts, it's a liquid. I get that. It undergoes a change. But if you think about the atoms, it's water before, it's water after. It's not a new substance. So phase changes, physical changes like that. That's physical properties. If I take this pencil and break it in half, okay, it's still the same material, even though it kind of isn't as same used as it was. It's not used as it was. It still ends up being the same material. So that's what we're referring to here. So like physical changes are grinding, cutting, melting, as long as it's the same material. Think about it at the end. If I take a ripped piece of paper, it is still totally paper. All right, so change of states are always physical properties. So when this is one that students often miss, is like evaporation. So when alcohol evaporates, it's still alcohol in the air, even though it's gone, right? It smells like alcohol. You put Purell on, everybody's putting Purell on, right? It's alcohol before, it's alcohol after. It's a physical change. It is no longer in the same state, but it's still the same material. And they talk about states of matter, solid, liquid, gas. It's below you, okay? So solids have definite shapes, definite volumes, that kind of stuff. I'll let you read that. So plasma is kind of interesting. So some books talk about this, but plasma is basically high temperature molecules where they've lost most of their electrons. And so it's kind of like charged particles. So you often see this in like a plasma ball. If you've ever seen those balls, you put your hand on it, it gets that cool look on there. The sun is plasma, so most of the matter in the universe is actually plasma. All right, now something a little bit different would be chemical properties. So this is like, remember we talked about when someone is smoking a gas, as they're pumping gas, you should run because that's a chemical property of it, is the ability to undergo a change and react. So some things we kind of just intuitively know, like if you leave your car out in the forest for like 3 years, it's going to rust. And a chemical property of metal is that it has the ability to oxidize with oxygen and rust. So that's something where it undergoes a chemical change, and there's, the old becomes new. Some sort of new product is made that has different properties. So if I take a piece of paper and burn it, anything burning, flames, that's always chemical change. You can write on it before, and then afterwards it's just a pile of ashes and the smoke is there and everything's different. And so it no longer has the same properties. If you could make like a tree stand out of fresh wood, it's going to be able to hold you. But if you make it out of rotten wood, which is chemically changed wood, you'll fall right through your tree stand. So keep that in mind. So in a chemical change, there's always some sort of reactants. So if I go back to my gasoline example, like gasoline would be a reactant, oxygen would be a reactant, and then it burns and produces something else that would be carbon dioxide, water vapor, that kind of stuff. Products are the things that are the new part that are made. They have different properties. So reactants always have different properties than products. We'll get into this. We'll be balancing equations this year, but this is just like a word equation. So carbon plus oxygen yields carbon dioxide. And these guys on this part right there, whoops, I went back. On the left are your reactants, on your right are your products. We'll get into the formula and all that. So how do I know it chemically changed? Well, this is cool, right? Oops, I pushed the wrong button. So you know it if there's bubbles. Oh, look at that. That is great. So usually if a gas is formed or smoke is formed, then it chemically changed. So for example, you're burning wood, right? There's smoke, or Alka-Seltzer, actually, or baking soda and vinegar. It chemically changes because the bubbles. So bubbles are in smoke, good evidence that it changed. Okay, a precipitate. So we review that PPT. Precipitate is when you mix something together and something chunks out, okay? Something insoluble forms. This is kind of a weird one, but This is very common in chemistry to make a precipitate. Now, when you see heat or fire or feel heat, that's often an indication of chemical change. And then the last one is if there's color change. So these are the main indicators of chemical change. All right, let's go on. All right, so this is just this is from your book. This is actually in your book, but they talk about the different properties of it. And so these are your reactants. You can actually take and burn mercury oxide. You can make oxygen and mercury metal. And these ones, if you notice, these have different physical properties before and after. And then the chemical properties describe how they interact. So like mercury 2 oxide is decomposing. That's a word we use for chemical change. Supports combustion, chemical change. For mercury, silvery white, again, color. These are examples of physical change. All right, and that's pretty much it. So what we're going to do now is we'll pick this up in the second part of the lecture later, but we're going to practice a little bit. So there's in your Schoology, all right, that's what we use. There's a CAMI on this one, and we're going to kind of do this together and talk about it with our lab partner at appropriate distances, people. All right, have a good one. We'll end this here.